And today in the workshop is a Sony Giga Juke model NAC HD1E, released for the connoisseur of piracy. This model was launched in 2007 for a hefty price tag of £700, but for that you do get a radio tuner, CD player and a 250GB hard disk. Up front it's all swanky push button controls and a single drawer for the CD player. Presumably this has got quite a swanky display, but I haven't seen it work yet. I'm not too busy around the back. There's the antennas, analog input and outputs, and various digital things. And this one has been delightfully customised by Gary in monochromatic marker pen, contrasting beautifully with the OEM silver finish. Not sure if he's into astronomy or loved heat lamps or was smoking pot, but that's not how you spell infrared. Now I'm not quite sure what's supposed to be wrong with this one, so I'm going to need to power it up. Luckily this one's actually got a decent plug on it for once, so in it goes. And on it goes. Well, it don't look very happy. Flashing standby light's never a good thing. Okay, so it's dead. Well, not totally. We saw inrush current and we heard the relay click on and off, which sounds like trouble, but to cheer me up I have invested in a new cordless screwdriver. Look at that. Ooh. Well, there looks to be quite a lot of stuff in here at first glance. You can easily recognise this 3.5-inch hard disk, all 250GB of it. And it's all connected together using this 40-pin IDE cable, the staple of many computer build in the 90s and noughties. And a horrendous digital board here with lots of chips with no legs. These BGA things are the stuff of nightmares. Let's hope there's nothing wrong there. The largest board at the bottom contains a few power supplies, and all the analogue stuff lives here, I reckon. And here's the main power board. It's got switching regulators and big chunky diodes. That'll be a bridge rectifier there. This must be the main power, but this thing isn't that powerful, so yeah. And this will be the main power transformer, and this will be a little switch mode standby power supply. Now typically when these things are dead it is the standby power supply, but I don't think so in this case. There's not a lot going on with the standby power supply. You've got the mains in, a mains out, and this little plug here with 4 wires on. Not a lot. Just want to check that digital ground is actually attached to the chassis, and it is. That's good, because I can just ground it to the scope. So I plan to measure 3 things all at once, so I'm going to stick 3 probes in. I've got the schematics of the little power board here. We can see here we've got a 4-volt output for the standby, that's easy enough. Ground. There's the output for the relay, which is coming from an external board, and we've also got another input here, which is to shut the thing down. Literally just clamps out the voltage. Wow. So I'm going to be looking at the 4-volt rail, the relay and the standby off drive. It's probably easier to do it on this board here, a bit more room. So I can find room in the plug, that is. It's a little bit cramped, so actually I'm going to do it there instead. So here goes. Okay, what this is telling us, the yellow trace is the 4-volt power supply coming alive. Nothing wrong there. The green trace is the relay. So the relay's been turned on and then straight off again. Why is that? So we see the relay is actually powered on this main board here. Follow the traces down. It's ultimately turned on by this transistor there, which is controlled by these here. So the power on signal, which goes into this bus here. We'll follow it down and look for power on again. There it is. It's controlled by a microcontroller, IC401. However, I am drawn to this bit here. It says emergency. What is that? So that goes back up to this bus. Follow it back up. Emergency's there. We follow this back down, follow the trace. There we have it. It goes to the power board. That is worth investigating. Pin 7. Looking at the schematics for the power board, we see pin 7 is the emergency signal. We follow it through, it goes up here. What does it do? So there's a Zener diode there. What's that? 15 volts going to a rail, which is 3.3 volts. So anything over 15 volts is going to put some juice on here. We follow it down. Same again, 15 volt Zener diode. This is the 5 volt supply. Again, same pattern, 15 volt Zener, 5 volts, and again 15 volt Zener and a 12 volt rail. So anything over 15 volts is going to drive the emergency line high. I can pull this probe out here because nothing happened on that pin and stick it in pin 7. If I can get the probe in, bit of a snug fit. Okay, going again. Well, that's very interesting. We don't see anything happening to the blue trace. Well, that has thrown me a bit. I was fully expecting that emergency line to have gone high, but it didn't. I still think it's a power supply, but what's wrong? Well, just to sense check this, I'm just going to disconnect the AC power to the board, see what happens. It's definitely that relay. Yeah, I can feel it. Definitely that one. Well, this is interesting. So the 4-volt rail is staying high, and we're seeing the relays being turned on and off continuously. I can pull some of these probes out because I think they're telling me all they're going to tell me. Well, I'll plug that AC power back in because, I'll be honest, that's not massively helpful being removed. I'm just going to unplug this connector, see if we're feeding something bad. Power on. Well, that's made no difference. I'll do this one as well. Power on. Still no difference. There's only one connector left here, might as well unplug that as well. I doubt it's going to work though. No, still straight on and off. I need to think outside the box here. I need to force that power board to stay on. Now it's fed from this transformer, so I think I can just disconnect this and power it directly. It just so happens I've got a mating connector for this, so I can power it up through these crock clips. Let's see what happens now. Well, there's no dramatic smoke, that's a good sign. I'm just going to move the chassis ground to the multimeter. I'm just going to probe the output voltages on here. The 5-volt rail is on D922, which is here. And there we have, 5 volts, perfect. There's a 3.3 volt rail on D912. 3.06 volts, that's might be okay. Then D942 is a 12 volt rail. There it is, close enough. And there's a second 5 volt rail on D932. Oh, that's a bit high, 24 volts. Oh, what's wrong there? Well, it's suddenly become apparent why it shuts itself down. So let's take that power board out. There's only a few screws holding this board in, shouldn't be too bad. One there, another one here. Oh, a little bit cramped up there near all the cables. Let's undo this cable here. Easy to undo when it's fastened down. There's that screw out. And just one annoying plastic clip to deal with. Come on. I think that's out. That's not how it's supposed to come out. Well, its clip's a bit mangled. I wonder how that happened. Someone's been in here before, haven't they? Yes, I think people have been in it. Look at this nasty soldering. What is that? We've put a link across where there's already a copper track. Why? This has been recapped, hasn't it? Oh yes, I see it now. Yeah. Uneven length legs. Okay. These aren't new, these are still glued in. What about these? Oh yeah, more dodgy soldering. Yes, okay. But can dodgy soldering cause a 5 volt rail to become 24 volts? This is the schematic of the 5 volt circuit, and you can see here we've got 22 volt rail here, and on pin 2 you got the 5 volts should come out of there. So we've got two scenarios. Either this is shorted on this device here, that will cause it, or if it's not shorted, this thing's switching it deliberately. You can see quite easily on this board that there's 4 identical circuits, well pretty much identical, just give different voltages out. You can see the controller chips here, built-in controllers and transistors. Nice 5-pin package. Let's have a look for IC932. And there it is, there's pin 1, moves the resistance to pin 2. There's no shorts there. So as there's no short between these two pins, this controller must be working its nuts off to get the voltage level on the feedback pin that it's looking for. Now it's supposed to be 1.3 volts here, which will be derived from the real output voltage and divided by this resistor network here. We should check this out. There's pin 4 there, for the little trace there, goes all the way to these little resistors here. Found them. I'm going to need the microscope for this. Well, here's the resistors in question, and what's this? That doesn't look very good. I'm not sure if it's right. Let's look at this circuit here. Ah, it's connected, definitely, and this one. Oh, there we go. Track damage. In fact, this soldering is very blobby. What about this one? Also blobby solder, but not too bad. So I'm going to tidy up these blobby solder joints and then fix those tracks. Probably best to remove some of this solder. There's rather a lot. Even though I'll have to put some back on. That one doesn't look too bad. These aren't terrible, just not very neat. I'll skip that one for now. It's as if this leg should be bent over that way to touch onto here. That would work. It is soldered down still. Just lift it up with the iron if I can. Push it slightly to the side. Let's put a bit of fresh solder around here. Not the tidiest job, but I reckon that'll work. Just loosely pop it back in here. Pop one screw in. Just connect the transformer output. And we'll see if that 5 volts is back to what it should be. Okay, D932. 4.76 volts. Well, that's better than 24 volts it was before. Certainly a lot closer to 5. What else have we got? So we had 12 volts on here. That's still good. 3.3 volts on here. Oh. What about this one? That's still 4.76 volts. 5 volts as well. Okay. Well, the 3.3 volts is very important on here, and I don't know where it's gone, but I've got a feeling it's more of an open circuit than a short circuit because there's a tiny amount of voltage left. And we can see on the schematic, we scroll up past the 5 volt converters and here we have the 3.3 volt one. It's exactly the same circuit. There can't be much wrong with it. I suspect it's missing the input voltage. It's all come off the same supply rail, look, all the way down here, all derived off the same 22 volts. I'll unplug the transformer again. I'm glad I only put the one screw in. And there's IC 911, pin 1 is there. Oh, bet you there's the problem. You can see there's been trouble from pin 1, look at this, there's already been a repair there, and it should be connected to these links here. But that looks a bit torn to me, look at that, the track's flexing. If I measure resistance from here to there, 37k. 47k. It's getting worse. I think I'm going to take the old repair off and start again with it. Looks like it's going to be connected across all 3 places really. From here, here and here, because this is basically disconnected from everything. Nasty. Just going to solder a bit of tin copper wire onto there. And bend it round here. Solder a bit there. Then hopefully let's check we've got continuity. Go from this link to pin 1. Perfect. We'll try that again. Let's chuck it in again, see what it does this time. There we go again. So check the 5 volts. Yep, okay. Next is the 12 volt rail. That's good. 3.3 volts. Okay, it's 3.05, it's a bit low for my liking, but it's there. And the other 5 volt rail. Okay. Actually, it's probably reading slightly low because I haven't got all the grounds connected. Probably not the best connection. Probably worth connecting all these now. See what else is wrong with this thing. We'll put the transformer back under control of this relay. Well, here goes, but I'm always a bit wary of these power supply faults, especially when it's tried to stick 24 volts up the 3.3 volt rail. That's not very healthy. Oh, it's dead. No standby light. Nothing. Have we still got the 4 volt standby supply? Well, not really. 2.24 volts, that's not working. Well, it was working. Let's take it out and have a look. So I'm going to unscrew the FM tuner module. That makes access a bit better. There's another one of those annoying plastic clips here. Should be good. There we go. Oh, we got more bodging going on. All the legs of these chips are all being bent over to make contact. They've ruined all the pads there. And all this going on around here. Looks like it's had caps again. So what's wrong with it now? We'll get the microscope out and have a look at this reworking that's been done. Well, all the pads on this chip are gone, but to be fair, it looks electrically sound to me. This side, yeah. This is good and solid. This is where the main capacitor is, the 400 volt one. Yeah, no problems. It's not the tidiest job, but I don't think the electrons really care. Just having a look for anything that looks a bit dry, like we've got some funny shapes there. I don't know if that is a dry joint or not. I might touch that up. The feedback for this is comes from some opto-isolators, so these resistors here, again, they look good. But hello, this doesn't look good, this is loose. I don't know why that's going to be reworked. Anywhere else? A favourite place to check is actually on the connectors where all the strain's going on. So that's over here, and oh, look at that, pin 1. That looks a bit iffy, doesn't it? Broken ring all the way around there. If I wiggle the wire, oh, look at that. I think I'll resolder the whole row. Just trying to find that diode I saw. There it is. Okay, and this part here. So I'm not sure what's going on there. I'm going to actually desolder this one, suck the rubbish off. Well, there is at least a whole ring around it. That's better. Just going to have a scout around and see if there's any other loose connections. But it all looks okay so far. Actually, I'm a bit intrigued why they've changed this large gap here, 10 mic 400 volts, but they haven't changed this one. So that 1 mic 160 volts. Let's have a look. Just drop the ESR meter across here, and oh, it doesn't even register. Barely. God, that's in bad order. Okay, I'll be replacing that one. Rather obnoxiously, they've bent the legs over, so I'm going to use the desoldering tool to straighten them first. Let's get that solder to melt. Lift it up straight. The same over here. And get at it. And on a rather comedic twist of fate, it looks like I've torn the track off as well. Damaging circuit board tracks happens quite a lot, especially when the circuit boards are cheaply made, which they often are, and even worse when they bend the legs over. It doesn't help. I'll be showing you how to put these right in my new training course and online community, so if you want to check that out, the Bend It Like Mark community, you'll see the information on the pinned comments. Anyway, we'll get back to fixing this. So I'm going to bear a bit of the solder mask off. Let's dig through there, get some bare copper. Well, in goes the new capacitor. We'll give that a whirl now. Put it back in. So we'll try it again. That's a bit better. The hard disk should be buzzing its nuts off as far as I'm concerned, making a lot of clicky noises, and it's silent. I heard the heads click when it immediately powered up, but there's nothing now. Let's check we got these voltages still. There's our plus 5 volts, that's good. 3.3 volts, good. 12 volts, and over here another 5 volts. No problems there. The IDE connector goes to this board here, so this is where all the silicon is, and I reckon this is where the problem lies. So it's difficult to find your way around this, so I'm going to systematically just disconnect things, see if it changes its behaviour. This is to the digital audio sockets. Take that off. Let's try that. And now there's no display, and still no activity from the hard disk. Just want to put it back in, so that's not changed it. Next nearest cable to the IDE connector is this one. This one actually goes to the display, so we definitely won't get a display now. So we'll give that a whirl. Still no action. Damn. I'm just going to probe these power supply rails here, see what's going on. Oh, it's not quite what I expect to see. They're all showing the same as well. That one's fairly stable. Okay, yeah. Yes. We'll check these caps here, because I have seen these go bad before. Well, that's measuring okay-ish. This one's terrible. Wow. This big one. That was measuring good, okay. This little one here. This one's no good at all. I can get in here. That was good. Over here, that was perfect. Must be very good. Still got some voltage across it, I guess. How about this one? Also perfect. And then finally over here, if I can get the probe on. Yes, fine. This little cluster of caps here nearest the IDE connector, pretty bad. Hopefully that's the cause of the trouble. So let's take this ribbon cable off here. Get that out of the way. I don't want to melt this plastic connector, so I'm going to put a bit of Kapton tape around it. Just to offer a little bit of protection. A bit over the top. And another piece again, just to sort of double line it really. Oh, it's stuck. Try and keep that in tight. Just going to warm the board up with a hot air gun. So these being power supply caps, of course, they'll be attached to the ground plane, which is probably some crazy whole layer on this. It's going to take a lot of heating up. And I don't want to tear the pads off this. We've seen a lot of pads being torn on this machine already. Try going in with the soldering tweezers. I don't have 1000 microfarad caps, so I'm going to skip that one. It does make it a bit awkward getting in here though. I'm going to put a conventional line down there. Alternate side to side. There you go, that worked. So I'm going to put a little bit of flux on these, so I can get this solder flowing nicely. Just add a little dab of leaded solder on top. Pop the new cap on there. Just need to tack it on. Press it down a little bit. Okay. Same thing. Tack it on. I think I can peel that off now. Plug this back in. It's always good when it still fits. You can plug the display cable back in as well. Well, we'll go for it again. And there's no display. What have I done? If I look at the schematics on the LCD board, I'll scroll down here. See if I can find that connector. And here it is. 9 pins. We got pin 3 is the serial clock, pin 4 serial data, power supply, and pin 5. Let's see if it's present. It'll be as if I tip this thing over. Okay, pin 1, that's the backlight contrast. That's floating around 1 volt. Okay, probably right. Pin 3. There's our serial clock. Nothing wrong with that. Pin 5 is the power supply, 5 volts. Yeah, that's good. Pin 2 is LCD power. Yeah, 3.3 volts, good. And then over here we got the data. And there's some data. Could it be a missing backlight supply? Something silly. Let's change the scale on there. That's like 24 volts or something. Nothing wrong there. There's no activity from the hard disk, and there's nothing on the display, and I'm not sure why. I'm going to park this video for now because other things need repairing. But if you're interested to find out what I'm going to do next with it, you might find out on the Mend It Like Mark community. Check out the comments for details. Catch you next time.